Everyone, welcome to Cloud Patashala's video series. Today in this video we would be looking into how to create a Kubernetes cluster in Google Cloud Platforms or GCP. For this, we would be going into the GCP console. We should be going into the Kubernetes section, that is Kubernetes engine from the extreme left. This would be under the compute part. You could go into the clusters, and if you don't have any Kubernetes clusters running, you would see this screen wherein you could either click on create over here or in the center, and you could select the autopilot mode in which Google, the GCP cloud would be responsible for provisioning the nodes and setting up the cluster for us. So I'll click on configure. I'll give the name for this cluster to be CPP00 cluster 1. You can select the region in which you want the cluster to be. I'll leave it as default. I would keep the network as it is, and all other options would be left as it is. I'll just click on create, and this should initiate the creation of our cluster. So as we see, a cluster 1 is being created, and so this is basically in the configuring state. From the configuring state, once all the configurations are done, it would also go into the deployment state itself, and then GCP would be doing a health check on its own and would be providing us the status of the entire setup. So we would wait for the setup to complete and for the cluster to be in the available state. As you see, the configuration is just now completed and the deployment is in progress. So as you see, the region in which the cluster has been created is US Central, and it is by default using 4 availability zones to set up the cluster nodes. In an autopilot mode, that is the kind of Kubernetes cluster that we created, we would not be able to edit the availability zones. It is totally in the discretion of GCP engine in the backend. The version of the GCP that is being deployed is 1.22.12, and this is the public endpoint that we would be getting for our system. The pod ranges is basically 10.1.128.0/17, and the inode visibility is enabled. The service address range is this, and we also have a lot of security and other related configurations as you see. So the deployment is finished, and we would now be waiting for the connection health checks to complete. In the meantime, what we could do is click on connect, and you could run this, and you could either copy this and run it in a shell, or you could directly click on run in Cloud Shell. So this would open a Cloud Shell environment for us and would run the setup. I always prefer to have this Cloud Shell running in a new window, so we'll probably wait for that to happen. So as you see that the cluster has come to the running state, and we would now be able to connect to the cluster. Since the Cloud Shell is already there in the next tab, we would copy this thing and paste it over here. This time, it should be able to fetch the endpoint details, and it should be the configuration should be generated for the cluster. So I could go into the kubectl commands and check the number of nodes that are available for us in the cluster. So if you see, we currently have 2 nodes available for us with version 1.22.12 running on them. So let's create a first pod and see if that works. So I'll just do this. I'll give the name I'll give the name for the pod as Nginx pod, and I'll give the image as Nginx, and this should create our first pod in the system. So I will do a system kubectl get pods, and this should show us that one pod is running, and we could also see the details of the pod uh, once it is coming into the running state. So we could definitely view kubectl ts describe pod this, and we could get all the information of the pod. So as you see, it currently says that it is waiting for the node to be available, and so once the nodes are available, it would be running the pods there. So if I again show you this, so basically if you see from the describe pod command, we got an output that 0 of 2 nodes are available, but it has insufficient memory and insufficient CPU available on them. This is because it is already running the GCP related services and stuff on it. So what this running of a pod has done is it has triggered a scale up. Now this is an automatic scale up that is happening on the GCP cloud, and we would be getting a new node, which is this. Now as soon as the node comes into the ready state, which it has, we should also get our pod in the running state, which it has now come to. I could again do a describe pod and the name of the pod, and you would see that we are able to run the pods on the Kubernetes engine. This is how we connect to the Kubernetes installation on GCP, and we could run our steps over there. I hope you like this short video on how we could create a Kubernetes cluster on Google Cloud Platform. Hope you like the content. Please like and share the video. Thank you so much for watching. If you're not subscribed to the channel, please subscribe to the channel, and see you all in the next video.